the way that we can find out how many possible roots there are to any polynomial. And you have to understand that there are basically two questions that are being asked. The list of all possible rational roots a lot of times is really lengthy. And the second question is, how many of those possible roots are actually answers? Right? So let's walk through this theorem and we'll see if we can make sense of this. So in our first example here, we have x to the fifth minus 4x to the fourth plus 2x cubed plus 2x squared plus x plus 6. A really lengthy polynomial, pretty scary looking. But what I want you to do is just focus on the lead coefficient and the last constant, the constant at the end, I should say. So the constant at the end is 6 and the lead coefficient is 1. Alright, the list of all possible rational roots of this thing is simply going to be c divided by a. But c isn't just 6, it is all of the possible positive and negative factors of 6. And a is the same thing. The possible positive and negative factors of 1. Alright, so this is kind of like what you want to memorize, right? This is how you compile your list. But keep in mind that it's not quite as simple as just saying 6 divided by 1. It's not that easy. So here we go. Let's figure out first, we want to find positive and negative factors of 6 and then positive and negative factors of 1. Let's do this one first. This one's pretty easy. You either have 1 times 1 or you have negative 1 times negative 1. I'm not going to write it like that all the time because, like I said, our lists are going to be pretty lengthy a lot of times. So I'll just go like this. Positive negative 1 times positive negative 1. And I just understand that if I'm using a positive over here, I have to use the positive over here. If I'm using a negative over here, I have to use a negative to the right as well. So they have to kind of be paired by their signs. Alright, same thing here. Positive negative 1, positive negative 6. Positive negative 2 times positive negative 3. Alright. So now we have to list our possible rational roots. So we're going to take x to be, like I said, c over a, and we're looking for all of the possible combinations of this divided by this. So let's just kind of jump right into it. Let's take positive 6, start with the biggest one, positive 6 divided by positive 1. Alright, so this is our list of possible rational zeros. So positive 6 over positive 1. How about positive 6 over negative 1? How about negative 6 over positive 1? And how about negative 6 over negative 1? Alright, let's go on to positive 1 over here. So it's 1 over positive 1. And we'll take negative 1 over positive 1, negative 1 over negative 1, or I guess positive 1 over negative 1. So as you can see, the list already is getting pretty long. Let's move on to the 3's. So let's go positive 3 over positive 1. So I'll go positive 3 over positive 1, positive 3 over negative 1, negative 3 over positive 1, negative 3 over negative 1. Move on to the 2's. 2 over here, so positive 2 over positive 1, positive 2 over negative 1, negative 2 over positive 1, negative 2 over negative 1. And that's it. Now it's kind of a silly thing to list it like that. First of all, we want to simplify everything. And secondly, some of these are repetitive. There are redundancies in here. Look at these. These are exactly the same number, -6. Right here we have numbers that are exactly the same. So the redundancies we need to eliminate the redundancies. We don't want redundancies. And we also don't want anything that's not simplified. So here we go. Here is our here's our list of possible rational roots. And of course, when we say rational, we're talking about something that is a fraction, right? And that includes integers. We can always write an integer as a fraction, something over 1. And we're going to put these in order of ascending or increasing magnitude. Magnitude meaning size. So neglecting the positive, negative, just write them in order of ascending magnitude. Alright, so here we go. Which one of these, let's see, we have 1, 2, 3, 4, 5, 6. Well, first of all, let's get rid of the redundancies. So we want to get rid of this guy. He doesn't belong. -6 over -1, that's also redundant. That's +6. We already have that over here. So we have +1. This is also +1. -1, that's also -1. So I'm getting rid of the redundancies. That's redundant. That's redundant. This is redundant, and this is redundant. So here we go. In order of ascending magnitude, so we want to go from smallest to largest. So we're going to go positive, -1, and we can write those kind of together like this. Positive, -2, it's down here. Positive, -3, and positive, -6. That's your answer. Those are the possible rational roots. All right, if we go to our graph, like I always like to, all right, I'm going to type this thing, this big polynomial into our graph. So I'm going to go to my good old trusty website, desmos.com, and see if we can't make some sense of this, because our next question that we want to ask is, what are the actual rational roots? Alright, so this is what, let me make sure I typed it in correctly, and I believe that I have. So this is what the graph actually looks like. Alright, let me zoom out just a tiny bit here. That's what the graph actually looks like. Alright, so if we go to like the important points here on Desmos, there's a button for that. I see that I have a -1, I have a +2, and I have a +3. Alright, that's a really, really easy way to figure out your rational roots, the actual roots where this crosses the x-axis. So we have, again, -1, +2, +3. So if our actual roots are, let me go back again, I forgot it. -1, +2, +3. So x equals -1, +2, and +3. These are our actual rational roots right here in green. Alright, and you can confirm that. Let's say you didn't have a calculator, or you didn't know how to use the calculator for whatever reason. You can confirm that answer by just looking at, maybe take one of those, right, and then we're going to do synthetic division. So if you wanted to start the synthetic division process, you would go and take the first one that you saw. Graphing is, of course, a really good tool here. Everybody has a graphing calculator. If you don't, you should have access to the internet. And we'll synthetically divide the polynomial. All right, the polynomial was x to the fifth minus x, 4x to the fourth, blah, 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 blah. So I'll write that back down here. X to the fifth minus 4x to the fourth. Let me go back up here, I forgot it. Plus 2x to the third plus 2x squared plus x plus 6. That's our polynomial, right? When we do synthetic division, you want to just take those coefficients. So the coefficient of the x to the fifth term is 1, negative 4, 2, 2, 1, and 6. And we're just going to do synthetic division, right? This is in a different video, so I'll go really fast here. All right, if this turns out right, then we should have a remainder of 0, and we do. So our remainder is 0. That means that negative 1 is in fact a root. It's a solution to this quadratic. Now, since we started with an x to the fifth, our next polynomial is going to be a fourth degree polynomial. So everything is just, once we factor, everything reduces, every exponent reduces by 1. All right, and then what you can do is, again, put that function into your calculators and repeat the whole process again until you get it down to a point where you are finished. All right, in any event, we are finished with this. Negative 1, positive 2, and positive 3. Next example. All right, let's go a little faster here. We want to extract a and, not b, but a and c. So the c term is 4, the a term is 1. All right, and we're looking for the possible rational roots, and we're going to get that from this formula right here. Really simple, where c is c, of course, is the positive and negative factors of 4, and a is the positive and negative factors of 1. So here we go. This is our list. I'll put it in red again for continuity's sake. These are our possible rational roots. So we go positive 4 over positive 1, 4 over 1, negative 4 over 1. I'm not going to write the redundancies this time. I think we're, of course you would go 4 over negative 1, but I'm not going to write that, right? We don't want to include the redundancies. So now let's go positive 1 over positive 1, and positive 1 over negative 1. Positive 2 over positive 1, positive 2 over negative 1. So we want this divided by this. All right, and that's really it. All right, let's simplify that in increasing magnitude order. Positive negative 1, positive negative 2, positive negative 4. And that's it. That's our list of possible rational roots. All right, let's go to our calculator. Never a bad idea to use technology to your advantage. I'm going to delete that entire thing and put in my new function. And of course you guys are probably using Texas Instruments, which is totally fine too. All right, so I look at this thing here, and I notice that I've got a function that crosses at a couple different points, right? And then if I could zoom on all those, right, I'm noticing that they're all decimal values, and they're decimal values that they actually aren't rational numbers. These are irrational numbers, right? So this function actually does not have any. It does not have any rational roots. No rational roots. All right, so these are the possible rational roots right here, but it turns out that none of them are actually true. So this polynomial here is going to have irrational roots. It clearly crosses the x-axis, so this is irrational, irrational, and irrational. All right, if we zoom in on that a little bit to get a little bit better idea, let me zoom in rather. All right, you can zoom in on that and kind of square it up here. You're noticing that there are actually 1, 2, 3, 4, 5. So these are kind of like really small little guys. Actually, that's not a root, that's a max, that's a relative maximum. So just 4 roots right here, but it happens that they're all irrational. All right, last one. So here we go. Let's go really fast here. The lead term is 3. The last term is 4. All right, so we're going to find factors of 4 and factors of 3. And that's it. That's a prime number, so it only has those 2 factors. And our formula again is all the factors of C divided by all the factors of A. That's like a nice little formula. So here's our list of possible rational roots. So here we go. Let's start with 4. Let's start with 4 and 1. We'll do the positive and the negative. So that's positive 4 over 1, negative 4 over 1. I'm not going to write the redundancies again. 1 and 1. So that's 1 over 1, 1 over negative 1. And let's keep going here. We want to go down here. Well, let's not skip around. 1 and 3. So we have 1 over 3, negative 1 over 3. Redundancies aren't important. Down here, 2 and 1. 2 over 1, negative 2 over 1. 2 over 3, negative 2 over 3. So that time I'm using the other combos. I have a lot of fractions here. That's not the greatest news in the world, but again, that's what rational means. It means a ratio or a fraction. So we have to expect that. So let's kind of simplify this, and we'll say, all right, that's positive negative 4, positive negative 1, positive negative 1/3, positive negative 2, positive negative 2/3. And again, we want to, I think I actually forgot one. Yeah, look at this, 4 and 3. Forgot that. Let's put that over here. So we have 4 over 3 or negative 4 over 3. So that'll be positive negative 4/3. I'm glad I caught that. And we want to write these in order of increasing magnitude. And by magnitude, again, I mean kind of size, the size of the number, neglecting the signs. So the smallest value of these, let's see, we have 1, 2, 3, 4, 5, 6. Out of those 6 possible rational roots, the smallest magnitude is 1/3. Next up, 2/3. Next up would be 1, and then 4 over 3, and then 2, and then 4. So that is our list of possible rational roots. All right, cool. Calculator time. So we have 3x to the 5th plus 2x to the 4th plus 9x cubed plus 6x squared plus 6x, what else? Plus 4. Okay, I'm going to zoom out to get a good look at this thing. And if I zoom all the way out, all right, I'm noticing that there's only one place where it crosses the x-axis, and that is at negative 0.667. That's a fraction. That's a rational number. That's negative 2/3. So negative 2/3 is our actual, I'll put it in green again, actual solution or root, rational root is negative 2/3. So all the other ones actually, aren't answers. The only answer right here is negative 2/3.